All right, so today we are on section 4, topic 5 and 6. Complex numbers. Complex numbers. So Algebra Nation, they have this spread over 2 different sections. I'm combining it into one lesson. Today is a C day, so we're not going to get very much finished. We won't get all of the notes for section 4, topic 5 and 6. Just the first little part, okay? All right, complex numbers are numbers that can be expressed in the form a plus bi. A and B are real numbers. And I, and it's like a lowercase cursive I, is the imaginary unit that satisfies the equation I squared equals -1. A is the real part. Of the complex number. BI is the imaginary part of the complex number. For example, if I said, what is the square root of 9? What would y'all say? 3. Why would you say 3? Because 3 times 3 is 9, right? And a perfect square is when you have 2 factors of that number that are identical, okay? So when I say what's the square root of 9, that means what 2 numbers did I multiply together to get 9, okay? Well, is the square root of 9 also -3? I heard a lot of no's. Well, tell me, what is -3 times -3? +9. So can't the square root of 9 also be -3? Yeah. So it's either +3 or -3. And usually when I ask for the square root, usually you only give me the positive square root. That's called the principal root. We don't always say +3 and -3, but it does have a negative square root as well, okay? What if I said, what's the square root of -9? What would that be? Undefined or no real number, okay? Because a lot of kids say, well, it's 3 and negative 3 is negative 9. Well, that's true, but when you take the square root of a number, isn't it supposed to be two identical factors? That is not two identical factors, right? And so there's no possible way to multiply two identical numbers together and get a negative. So up until this point, we say no real number, or we say undefined, until today. So all this time, y'all been dealing with a real number system. In your whole math life, it's been all about real numbers. Today, I teach you about imaginary numbers. I know, it's exciting. Like, what? Imaginary? Okay. An imaginary number, all that means is you're taking the square root of a negative number, okay? You do not get a real number as your answer, but you can get an imaginary answer. I know it sounds crazy, and it is kinda, but not a big deal. An imaginary number is the square root of negative 1, and that equals I. That's basically the definition. When you take the square root of negative 1, it's either no real number or it's I. Cursive, lowercase I. That means imaginary number. Okay? And another important fact, I squared equals negative 1. So I just means the square root of negative 1. But if you see I squared, you never leave that, okay? If it's I squared, you always replace that with negative 1. Which is not going to be really important to us today, but it will be during the next lesson. So the most confusing thing about today's lesson is when we simplify radicals, okay? It's really not the imaginary number that's confusing. It's simplifying radicals that students have the most trouble with, okay? Because we're not just plugging it into the calculator and getting an answer. No decimals here. We are going to simplify it and leave it in radical form. Now, if you try to simplify a negative number in your calculator, it's going to tell you non-real answer, okay? It's not going to say anything about imaginary. Your calculator does not deal with the imaginary number system. It only deals with the real number system. So that's why it'll always say non-real answer. Julio, ready for some examples? Let's do it. What is this about? Not even candy. Are you finished? Are you finished? Okay. I thought you told me. Hold on. No. All right. Here we go. First example. So my directions say simplify to find all solutions. When it says all solutions, that means real and imaginary. If your directions just said simplify to find real solutions, if you got an imaginary solution, you would just say non-real number. But if it says all solutions, that means it wants your real and imaginary. So you can't just write non-real number, you have to give it the imaginary solution. All right, example 1. Square root of negative 18. So before today, you would have just said no solution or no real solution, right? No real answer. But today we're looking for imaginary answers as well. So this first one, like, I'm really going to break it down, show each step. I know when you do this yourself, you don't have to go through this whole process, but your notes, I want you to see everything. So would you agree that the square root of negative 18 is the same thing as the square root of negative 1 times 18? Would y'all agree to that? Okay. What did I just tell you that the square root of negative 1 is equal to? I. So when you take the square root of a number, whatever that square root is, you put it outside of the radical, right? All right. Is 18 a perfect square? What's the square root? So is that a perfect square? No, not a perfect square. But it might have perfect square factors, and if it does, then we have to simplify further, okay? So somebody tell me some factors of 18. 6 and 3, 9 and 2, 18 and 1. Anything else? Okay, any of those factors that we listed, we said 6 and 3, 9 and 2, 18 and 1. Are any of those perfect square factors? Besides 1, 1's not going to help us. The square root of 1's 1, we'd still have 18. But any of my others, are they perfect square factors? 9 and 2, right? So I would, instead of writing square root of 18, I square root of 18, I would replace that with I square root of 9 times 2. What's the square root of 9? 3. So when I take the square root, I put it on the outside. If there's something already on the outside, just multiply it together. So what do you think 3 times I is? 3i. A lot of kids think you put 1 3 on the outside of the radical, 1 3 under it. You don't do that. Square root of 9 is 3. It's not 3 square root of 3, okay? So the only thing that we put under the radical is a 2. And anything under the radical is called the radicand, R-A-D-I-C-A-N-D. Do y'all remember that? Radicand. And so you know you're finished when what's under the radical, its factors, don't have a perfect square except for 1. 1's okay. But factors of 2 or 2 and 1, that's it. Can't be factored any further. If, say, that was 8 under there, and 8 has factors of 4 and 2, 4 is a perfect square, you could go further. Okay, everybody cool with that one? So 3i squared root of 2 is my answer. Example 2. Square root of negative 36. Anybody know what they think the answer is? Six I, that's it. Isn't 36 a perfect square? Yeah, so square root of 36 is 6, and the square root of that, I could change that to negative 1 times 36 if I wanted. The square root of the negative 1 is I, so that would just be 6i. If you have a perfect square, there's nothing to leave under the radical. Okay? Example 3. Square root of negative 50. What are my factors? Could I multiply together to get 50? 5 and 10, 25 and 2, 50 and 1, but that doesn't help us. Do either of those have a perfect square factor? 25 and 2, right? So could I change that? I'm going to go ahead and take the square root of the negative, which is an I, and I'll replace with 50 with its factors of 25 and 2. A lot of students, if they start with 5 and 10, they're going to say, well, neither of those are perfect squares, so it can't be simplified any further. But that's not true. Okay, it can. Because 5 times 10 is the same thing as 5 times 10 has factors of 5 and 2, right? Well, so if you break those down further, you're going to see that you have a perfect square in there. But a lot of students don't, so be careful about that. Okay, what's the square root of 25? 5 times the I that's already on the outside is 5i square root 2. Can 2 be simplified any further? Nope, that's it. Example 4. Square root of negative 7. What are the factors of 7? 1 and 7. That's it. What do we call a number whose only factors are 1 in itself? Prime. Am I going to be able to simplify 7? No. Should I leave that negative under the radical? No. So what's my answer going to be? I square root 7. That's all we can do. I have 2 more. That's it. Then your assignment. Example 5. Square root of negative 120. Now when you get numbers that are bigger, you can still write factors like I did, but to me, I'll make a factor tree. You don't have to make a factor tree. I make a factor tree. Y'all remember factor trees? So somebody just give me 2 numbers that make 120. It doesn't matter what it is. 60 and 2. And I always underline the prime factor, okay? If it's not prime, keep going. What do I multiply together to get 60? 30 and 2. 2 is prime. Factors of 30. 6 and 5. That's fine. Could I use 15 and 2? Yeah, right? Either one, it doesn't matter. Because once I get to the prime factors, they're all going to be the same. So 5's prime. Factors of 6. 3 and 2. And those are prime. So once you get all your prime factors, I write them in a row. I've got 2 times 2 times 2 times 3 times 5. 2 times 2 times 2 times 3 times 5 is 120. If I have 2 numbers that repeat, they make a perfect square. Okay? So like, I don't want to include this other one in there because it's going to make a perfect cube. I need a perfect square. So what's 2 times 2? 4. And 2 times 3 is 6 times 5 is 30. Does 4 times 30 give me 120? Okay, so that's the factors I'm going to use. All right? So I know the square root of a negative is I, and I will change 120 to 4 times 30. What's the square root of 4? 2 times the I that's already out there is 2I. The 30 stays under the radical. Now, does 30 have any perfect square factors? I don't think so, but let me see. I know 5 times 6 is 30. 2 times 3 is 6. Do I have any prime factors that repeat? No, and I already knew over here my prime factors were 2 and 3 and 5, right? But just in case you were confused, 30 has no perfect square factors other than 1, and 1 does not help. So it's simplified as far as you can simplify. Last one. Like I said, this is not all of the information that's found in this section. This is just all we have time to cover today. We have the square root of negative 150. It's the square root of negative 1. Is 150 a perfect square? No, let's do a factor tree. Somebody give me 2 factors of 150. 15 and 10. Are either of those prime? Nope. So give me factors of 15. 3 and 5, those are both prime numbers. So factors of 10. 5 and 2, and both of those are prime. So my factors are 2 times 3 times 5 times 5. Does 150 have any perfect squares in it? 5 and 5 give me 25. So that means that 6 times 25 is equal to 150. 6 times 25 equals 150. So I will replace that. I always like to write my perfect square first. You don't have to. That's just what I like to do. If I had 2 of the numbers that were the same, I knew that was going to make a perfect square, 2 identical factors, and then whatever I have left, I just multiply it together. I always write it in order, you know, least to greatest, and then so my same terms will be next to each other. Whatever those are, I multiply them, that makes a perfect square. Everything else, I multiply it together. Now, say you had 2 5s and 2 4s then the 5s would make a perfect square. The 4s would make a perfect square. 2 perfect squares multiplied together is going to make a perfect square too. Okay, what's the square root of 25? 5. I got the I already out there, so I multiply. 5i square root 6. Does 6 have any perfect square factors other than 1? Nope. So that's my answer. Easy? Y'all know how to simplify radicals now? Little better than you did before you came in here today? Oh, good. All right, so I will pause the video and give you a classwork assignment. Hopefully y'all finish today so that you won't have homework.